Hello everyone, and welcome to your video on moving graphs off the origin. So the first thing that I want to talk about is the lovely circle. And you know that the general equation for a circle is x squared plus y squared equals r squared. And we know that the ellipse has the general equation of x squared over a squared plus y squared over b squared equals 1. And we know that the hyperbola has the general equation of x squared over a squared minus y squared over b squared equals 1. So this is all well and good as long as the figure is centered around the origin. As soon as we want to make our circle move off the origin, or our ellipse, or our hyperbola, we introduce two new letters. We introduce h and k. And this is the x value and the y value of the new center point. And we modify our original equation by sticking h and k in there, messing with our x squared and our y squared. So a circle, for instance, would become x minus h quantity squared. So instead of just squaring the x, we square the x minus h, plus y minus k quantity squared equals r squared. That's our new equation for the circle. The equation for the ellipse is the same thing. Instead of x, we do x minus h quantity squared, still over a squared, so that doesn't change, plus y minus k quantity squared, still over b squared, that doesn't change, equals 1. And our hyperbola becomes x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So you see that all of our formulas are the same, exactly the same, except that we subtract an h from your x value and we subtract a k from the y value. That's it to moving graphs off the origin. So let's look at an example equation and see what you can figure out. So let's say that our equation, this is a circle, is x minus 5 quantity squared plus y plus 3 quantity squared equals 12 squared. So that would be our radius, a radius of 12. All right, so what is the center to this equation? Well, our center is going to be positive 5 and negative 3. Positive 5 and negative 3. So you'll notice that we're switching the signs here. Here we have a negative 5 and it becomes a positive 5. And here we have a positive 3 and it becomes a negative 3. And you might have in your head the question, why? Why do these signs change? Well, let's just review. Our original equation is x minus h quantity squared plus y minus k quantity squared equals 12 squared, right? Well, if our center is a positive 5, that goes here, and a negative 3 would be our k, that would go there. So then it would be x minus 5 quantity squared plus y minus negative 3 quantity squared equals 12 squared. So you can see that this is going to become plus a positive. So we wind up with x minus 5 squared plus y plus 3 squared equals 12 squared. That is the original equation. If I were to have a negative 5 in here, then my sign would wind up being wrong in my formal equation. So I need to flip the sign. If my original equation had a plus sign in it, this would be no problem. But because it has a minus sign, I have to flip these signs. So let's do another one just to, make sure you're catching on here. So let's say that we have this formula. We have x plus 4 quantity squared over 16 plus y plus 2 quantity squared over 25, and that equals 1. So first ask yourself, what type of figure is that? And you should know that that is an ellipse. What is the center of this ellipse? Well, the center is going to be negative 4. So again, we're switching the sign. And negative 2. That is your new center. And again, let's pretend. Let's pretend that we are a wrong student. And so we say that our center is at positive 4, positive 2. Okay? That's wrong. Let's see why it's wrong. Well, here's our formula is x minus h squared over 16 plus y minus k squared over 25 equals 1. If we were to fill in the wrong number, we would get x minus 4 quantity squared over 16 plus y minus k quantity squared over 25 equals 1. And you can see that this equation, which had the wrong center, does not equal this brown equation here, which was the right equation. So this one is right, and this one is wrong. So hopefully you can see by working backwards that if you don't flip the signs, you don't get the right equation. We need to flip the signs so that our equation turns out properly. Okay, now the only other thing that makes this hard is that once you calculate your new center, that needs to become the center of your whole universe. So, for instance, let's do this equation. Let's do x minus 3 quantity squared over 4 plus y plus 1 quantity squared over 9 equals 1. Now, you should know from looking at that that is an ellipse. And you should also be able to tell from looking at this that our center is not at the origin. What is our center? Well, our center is positive 3, negative 1. Okay, great. So let's graph this beast. Center is positive 3, 1, 2, 3, 4, 5, 6, and negative 1. Positive 3, negative 1, right here, I'm going to mark it 3, negative 1. Okay, my A value is 2, and my B value is 3. So I'm going to go along the x-axis, left and right, horizontally, 2 spaces. I have to make sure, though, that I count from the center, not from the origin. So here, if I were to add 2 to my x value, I would go over here and I would wind up at 5, negative 1. And if I were to subtract 2 from my x value, I would end up here at 1, negative 1. Okay, so you see that I have moved still 2 spaces to either side of the center, but I'm doing it from the center, not from the origin. So I cannot just look at A equals 2 and think that my points are going to be on point 2. In fact, none of these are on point 2. All right, and then I can also calculate my B change by counting 3 up, 1, 2, 3, which is my x value stays the same at 3. My y value goes up 3. So that's going to be at positive 2, right? Because negative 1 plus 3 makes positive 2. And then I can also count down, which would be about here, which would be at 3, negative 4. Okay? And then I can draw my ellipse, which looks like that. Okay, so far so good, and usually people are pretty good about that. The problem that they run into is when it comes time to calculate the focus. So remember, our major axis, that is the longer one, which in this case is B, that is going to be where we have our foci for an ellipse. And we can calculate where each focus is through a formula. And that is going to be a squared minus b squared equals c squared. A squared is 4. B squared is 9 equals c squared. And I can see that I'm going to have to take the absolute value, right? Because I don't want c to equal a negative number. So that doesn't make any sense. I can't have a negative distance for my focus. So c squared is going to equal 5. So c equals plus or minus the square root of 5. All right, so let's see what that looks like. First of all, if I put in my calculator the square root of 5, I get about 2.2. I do that just so that I can draw my graph semi-accurately. So I'm going to measure 2.2 up and 2.2 down from the center. That's the key part. You have to measure from the center. So we go 2 up, 1, 2, that's right there. And then we go 1, 2, and we don't say that this is exactly at point 2.2. So we're going to want to use an exact measurement here. And hold on, let me get a different color for you. I got a gray. Okay, so this focus is still at an x value of 3. But the y value is at this weird place. You can't call it 0.5. I mean, you can't call it the square root of 5 because it's not that high up. It's 2.2 from the center. So we're going to call it negative 1 is where it starts, and then we will add the square root of 5 to it. And then down here, this is still going to be 3 on the x-axis, but it's going to be negative 1 minus the square root of 5. So again, you are adjusting the square root of 5, but you're adjusting from the center. So you take whatever your center point is, and then you add or subtract that c value. And that is pretty much all there is to it. The focus is the hardest because you are most likely to get a weirdo number like the square root of 5, right? It's kind of hard to get perfect square, perfect square, perfect square all at once. So it's likely to be a little bit funky. But that is the way you move things off the origin. And then once you move it off the origin, you have to make sure that all of your calculations come from the center of the figure. And that is all there is to it.